Good afternoon, everyone. I hope you're all safe and well. This is Christina Osborne with ISO Stakeholder Affairs, and I'd like to thank you for joining the informational call. This is to go over the 2020 California ISO Summer Assessment, COVID-19 impacts on ISO loads and markets, and then finally GMC rate and EIM administrative fee adjustments. So we posted the presentation yesterday. You can find it out on the miscellaneous stakeholder meetings webpage. That's located under the Stay Informed tab. Go to meetings and events, and you'll find the miscellaneous meetings linked there. We are also recording the meeting today. We're going to make that recording available for a limited time on that same webpage for your convenience. Oh, I did add a resources slide at the very end of the slide deck. It includes a link to the summer assessment, which was released in mid-May, and then also a link to the GMC rates and other fees. That spreadsheet includes the charge codes. So those two items are linked at the very end of this presentation. What we're going to do is we're going to go through each presentation, and then we're going to pause for questions. So if you do have a question, you can raise your hand by pressing #2, and we just ask that you identify yourself first. So with that, before we start with the summer assessment presentation, Joanne Serena from ISO is going to kick it off. Joanne?
Thanks, Christina. Good afternoon, everyone, and really appreciate everybody joining today and hope everyone is doing well. I just wanted to mention that we obviously have three key topics that we wanted to cover with you today. There are three topics that there is some overlap, but there's also some uniquenesses about each of them. And so we felt that it was really important to cover all three of these important topics in a very timely manner, given what's happening with, we're in a heat wave right now, and I'm sure people are very interested in what their summer outlook is going to look like. We've had a lot of questions about our load forecast and the impact that COVID-19 has had on the load across California. And then most recently, our GMC rate increase. We've had some questions about that, and so we're happy to share some details on all three of these topics. So thanks again for joining, and look forward to what some of the questions and inquiries you might have after each of these topics. So with that, I will turn it over to Bob.
Well, thank you, and good afternoon, everybody. So to get into the summer assessment, the ISO develops a summer assessment report every year, and the purpose of the summer assessment is to really take a look at the conditions that we expect to see throughout the summer season coming up. What are some of the supply and demand conditions that we're aware of that may be unique for this particular year, and to model all of those conditions, and then utilize those results to develop a report which helps to inform the California ISO operations team as well as market participants of what we think the likelihood of potentially going into a condition where we may actually have to shed firm load. And while those conditions are typically pretty minor, pretty low probability, we also want to take a look at just what are the conditions that would be most challenging throughout the summer season. And this helps our operators as well as market participants to really be able to prepare for those kind of conditions ahead of time, so that if they do occur, then they're ready to, have already practiced it and have a plan in place. So to get into some of the basics of the simulations that we perform, the summer assessment report presents results from 2 stochastic model runs. And each of the 2 stochastic model runs is a model based on 2,000 different scenarios that we run. Those scenarios are designed to develop a probability of what actual historical weather conditions have been over the last 25 years. So it's a full range of every weather condition that we've seen since 1995 forward, as well as modeling historical profiles we've seen for both wind and solar, as well as a few other non-dispatchable type resources. So for the base case this year, we utilized a little different technique for the import limit than we have in the past, where for the base case, we're modeling the historical imports in a limit, and I'll speak to that a bit more, what that limit is all about. And then we performed also a moderate sensitivity case where we used more conservative import limits. As far as some of the key inputs that are in the model and things that drive the results that are worth kind of speaking to at the very beginning, rooftop solar continues to offset load growth and has pushed the system peak to evening hours when solar is no longer available. As a result, the adequacy levels are more challenging in the post-solar window, as reductions in the gas fleet have not yet been offset by significant storage to offset the loss of capacity available during that window. So while over the next 3 years there's procurements that we're expecting to see up to 3,300 megawatts of additional capacity procurements occur from the load serving entities in the next 3 years, and we anticipate that the largest portion of that amount will be storage. But going into this summer, we only have about 350 megawatts of storage, of battery energy storage anyway. And so we are pretty limited in that capability this year, and we're hoping that will slowly evolve to where we have more and more storage to be able to deal with that. And reliance on imports climbs late summer when the impacts of below normal hydro conditions are more pronounced. So I'll speak more about the hydro conditions as we go through this presentation. So next slide, please. So for the input assumptions, the 2020 load forecast is relatively unchanged this year from last year. So as we see some moderate growth, all of the growth that we would see in load is basically moderated by additional behind-the-meter solar coming online, to where the net result is basically an unchanged forecast from last year. For hydro conditions, the California hydro is close to the 2018 conditions, where this year the snow water content in the California mountains peaked on April 7th, and it peaked at 63% of average. As comparison, last year we had, it was 162 plus above average. So we were significantly above average last year, to where this year we're only 63% of average. The reservoirs this year are at 101% of average, and Northwest Hydro is at 95% of average. We'd like to take a look at the Northwest Hydro because that's an area that we typically see significant imports coming from. So that looks pretty close to average. That's a good thing for us for the summer. Moving to generation, the system capacity for a time of peak, you can see the numbers that we have from July, August, and September, where these are the amounts of capacity that's available to meet our peak demand conditions later in the evening. And you can see how it declines through the summer. And the decline is primarily due to the declining amount of hydro that we would expect to see through as the summer progresses on, as well as the net qualifying capacity of solar being diminished as we move through the summer as well. So that accounts for that declining amount through the summer. As far as retirements and additions, you can see both of those are very close to 2,000 megawatts. So virtually a net no change in additions and retirements. And these numbers are based on the net qualifying capacities of those resources based on the effective load carrying capability methodologies. Looking at the caps that we put for net imports, to speak to that a little bit more, our models, as I said earlier, a broad range of conditions across California, broad range of weather conditions, and but we also modeled the rest of the WEC, and the rest of the WEC is modeled at 1 and 2 load conditions. So with that being the case, the model typically can find plenty of surplus energy and other BAAs that are available for imports into the ISO. So we need to put a cap on that in the model so it doesn't bring too much imports, more than we would see that we've ever seen historically. And we've been using that process ever since we've been using the stochastic model. This year we did a little bit of different. I'll speak to the nomogram we developed for the on-peak period in a moment. But first, the off-peak period, what we did for that is we looked at the amount of actual imports we've seen crossed 8760 hours last year, and what was the maximum amount we saw? So we allowed the model to go up to that maximum amount of 11,666 megawatts during the off-peak periods. However, during the on-peak periods of hours 16 to 21, where we typically don't see that level of imports, we developed nomograms for both the base case and the conservative import case, where in the base case we set the nomogram to capture the vast majority of the historical imports that we've seen. For the conservative case, we developed that based on what we consider more realistic levels of imports, particularly in mind of if we get into a situation where California is in a heat wave and that heat wave is extended out and impacting balancing authorities that are neighboring to us, places that we typically get imports from, that if they are in that same condition where they're seeing a heat wave where it may actually they have to rely more on their surplus energy and less would be available to the California ISO. So that conservative import case is designed to actually capture that condition. So the next slide, please. I did want to speak to the impacts to load due to COVID-19 and what we did in the summer assessment, which really we made no attempt to predict any potential ongoing impacts to loads due to COVID-19 through the summer period. At the time we were running the modeling back in August, we had just gotten into the conditions that were being driven by COVID-19, and at that time too many unknowns existed to produce a viable and meaningful COVID-19 load impact scenario for inclusion in the summer assessment. And in reality, we're still in that boat, but even more so back then. The 2020 summer weather is just really now starting to materialize within the summer conditions where we're starting to get into the air-conditioned driven loads. But at that time, we hadn't seen any air-conditioned driven loads yet. And even now, as we're just starting to get into that, and loads are starting to climb, they're nowhere near the 1 and 2 forecast for the summer yet. So we really don't have any good data as to how these changing loads are going to be impacted by the air-conditioned driven loads that really drive the California ISO peak demand. So while the California ISO does recognize that there are likely to be lasting effects from COVID-19 through this 2020 summer period, there's not enough data to forecast either the magnitude or the hourly profile of those impacts. The model, again, is an hourly model, so if we were going to model the magnitude, we would need to be able to develop hourly profiles for all of the weather conditions, and we're just not at a point where we have data to be able to do that yet. We're moving on to the next slide. Just want to speak a little bit more about the hydro conditions. This chart here on the left, or excuse me, on the right, shows the snow water content within the California mountains, where the blue shaded area shows the historical average across the period from December through July. And then the red line is what we saw back in 2017, 2018 for snow water content. And then the blue line shows what we are at this year as of when this particular graphic was pulled from California Department of Water and Power. So you can see that these numbers are very similar to 2018, and the way we do the model is we look at hydro conditions and try to find a year that's very similar to it, and if we can find that hydro year that's similar to what we expect this year to be, we utilize the actual generation both in capacity and energy on a monthly and even daily basis to be able to model that through the summer so that we can have some what we consider realistic levels of energy generation from the hydro fleet. And why don't we move to the next slide? This is a slide where we got our information, or at least the data that depicts the data we use to get the 101% of average for the reservoirs across California. These are the large reservoirs across the state, and these really represent water delivery capabilities as much as anything. They're not quite as representative of hydro because these reservoirs really don't represent the majority of hydro across California. The hydro that is behind these various reservoirs is not by any means the majority of the hydro. So while this looks really good from a water delivery standpoint, it really doesn't speak very much to how much is available from the hydro fleet for this year. So moving on to the next slide. So this slide is to demonstrate how we developed our nomograms. It's much more in depth than just this one slide, but this is used to illustrate really how the nomograms look against historical import levels. So this graph shows the on-peak net import cap nomogram for the base case and the conservative import sensitivity, where each of these dots is the amount of imports we saw at time of peak for any time that we had a daily peak of 41,000 megawatts or more over the last 3 years. We chose 41,000 megawatts as a starting point because that is within 90% of the 1 and 2 peak demand forecast for this year. So looking at the top dashed line, that purple line, the base case nomogram, you can see that it pretty much captures all of the dots. Only 2 dots of import levels were above that. And looking at those, we felt that those particular conditions are not something that we really wanted to model. They were conditions that where we had a late peak in September, and while it was hot in California, it was pretty mild in other areas, and so there was plenty of capacity for imports. So we developed a nomogram that captured everything other than those 2 points. And then a lower nomogram is for the green line for the sensitivity case. And in this case, we looked at where we really thought imports would likely be under conditions where we would see more of a widespread heat wave, more than just California. And what would the imports be under those type of conditions that we felt we could be more comfortable in saying, yeah, we think we can rely on imports at this level. So that's how we developed that particular nomogram, and you can see that it captures most of the import levels. But again, we had a heat wave back in 2017 in September where imports were very strong, and a lot of those dots are actually from that particular event where we had a few days of high heat in September, and imports were pretty plentiful at that point in time. But we don't know that we can really feel comfortable to rely on those levels this particular year. So moving on to the next chart. So this shows the results of the 2 scenarios that we ran, the base case and the sensitivity case. It shows the import limit impacts the probability of system capacity shortfalls. So this shows the probability of actually having a system capacity shortfall. And to demonstrate that, we use the criteria of stage 2 emergency, a stage 3 emergency, and unserved energy result from the model, where a stage 2 condition is where we are at a condition where we are able to meet the operating reserve requirements of 6%, or we are starting to fall below that 6% level, to where there are no more there's no more resources out there to actually get us back to the 6% level. So once we cross 6%, we just or get to 6% is a typical point. We declare stage 2 emergency, and we continue in a stage 2 emergency condition until if the reserves continue to decline to where we get to a stage 3, which is a point where we are now at a 3% operating reserve condition, and there's no more resources available to get us back to our full operating reserve requirement. And so a stage 3 is that range where we get to 3% or less. And at that point is where we would consider firm load shedding. If we are at 3% and it looks like the reserves are going to remain stable at that level and loads are starting to decline, we may not actually shed firm load under that condition. But if we are at 3% and we see the loads climbing and where our reserves are going to continue to diminish, that's the condition that we would actually start to shed firm load. And then unserved energy is a result of the model, to where in that case we are at an operating reserves are 0 and we still are not able to serve all loads. So there's a component of load that still cannot be served even with 0 operating reserve margins. So to look at the probability of each of these conditions, starting with the unserved energy, go from the bottom up to where you can see they're pretty low probability, very low within the base case, only 0.2%, and in the sensitivity case, 1.6%. Moving up to the stage 3 condition, which is really the better place to start looking at because that's really where we're going to start to shed firm load. For the base case, very low probability. Every scenario that, set of scenarios we run, we always have some probability of getting into a stage 3, but, numbers at 1.1% are very low and not alarming. When we get to a level of 4.7, nearly 5%, that's almost five times more than the base case. So the sensitivity case starts to get to a point where we start to get a little bit more concerned, and so that's a level that is definitely more concerning than the base case. And then looking at the stage 2, 3.7% for the base case to get into a stage 2 emergency, again, very low. Getting into the sensitivity case, it's nearly 11%, so we're at a point where, 1 in 10 conditions will get us into that condition. So it's starting to get into the realm of possibilities where 1 in 10 is not so extreme that, we start to understand that there's a possibility to be getting into that mode. So it's while I wouldn't consider it alarming, it's something that we definitely want to keep an eye on. And the conditions that were in the model assumptions that we might find ourselves in this summer. So to move to the next slide, this chart shows the distribution of what we call the minimum unloaded capacity margins for the base case. And the unloaded capacity margin is the amount of capacity that is available or surplus above loads for each hour within the model. And we define the unloaded capacity as any capacity that can be brought online to serve load within 20 minutes. And so what that entails are generators that are online have been dispatched, but they have not been dispatched to PMAX. So there's some headroom available for them to be dispatched higher if needed. And it also includes units that can be brought online within 20 minutes to serve load. And the probabilities are shown here for each of the conditions for stage 3 and stage 2. So for the base case, those probabilities of the stage 2 and stage 3 are pretty low. Looking at the pink shaded portion on the right, if you go to the very far right bar, you can see 0% operating reserve margins, our minimum unloaded capacity margins. We have 3 scenarios that were in that case. So only 3 scenarios had 1 hour or more. And in all, there was only 4 hours where we had unserved energy through the base case. And then looking at the other bars that are in the stage 3 emergency case, only 1.1% of all scenarios had at least 1 hour in that realm, so very low probability. Moving on to the next slide of the conservative import case. Again, moving to the right side, looking at that pink shaded area, where on the far right you can see that there were 31 scenarios at 0% operating reserve margin. Those are the scenarios of unserved energy. So in this case, we had 31 scenarios in that case with a number of hours within those 31 scenarios that had unserved energy. And looking at those particular hours within those scenarios, we found that 85% of those hours were between August 28th and September 28th. So what that means is as the hydro conditions continue to diminish late summer, and also we start to see the solar fleet having an earlier sunset and not producing quite at the same levels, those are the hours or the time period of the summer where we're really at greatest risk. So just to look at also the remainder of the scenarios in the stage 3 emergency condition where we're at 4.7%, you can just start to get a feel for the profile of conditions and scenarios where we actually are in a stage 3 condition and stage 2 condition. So more cases in these scenarios to where they start to get into the realms where we think, well, it doesn't take extreme conditions to get us there. So it helps operations just understand the likelihood based on the imports that we're assuming for that particular case. So moving on to the next slide, this shows the actual hour of the minimum on-load capacity margin, the hour that it actually occurred in each of the 2,000 scenarios. And we also show the solar generation profile on this chart. And what this demonstrates is that over 90% of the conditions where we had the minimum on-load capacity margins are when we were at very low to zero solar production. So we're in a mode where we're serving our peak load for the day. Peak load has now moved to post-solar production hours. And so we're finding that the greatest risk is when we're in the post-solar production hours where we have to rely on the remaining of our fleet, the non-solar portion of our fleet, to meet our peak demand load. And therefore we find, that's the area of our greatest risk these days. And so that's why we'd sure like to see some additional storage come on to help be able to serve that load post-solar production hours. Moving on to the next slide, you can see this is virtually the same. This is for the conservative scenario, and really the profile here is virtually the same for these two scenarios, so that even though while the results of the magnitude of shortages are different, the actually hours that those shortages would be occurring is virtually the same. So it just shows that regardless of the amount of imports we have, it's really the same hours, the same conditions that we're having to deal with, which is the hours of post-solar generation. So moving on to the last slide, this is the conclusions, where this summer posed a somewhat increased risk of encouraging operating conditions that could result in operating reserve shortfalls than was projected last year. As I said earlier, last year we had over 162% of average for hydro conditions, where this year we're at 63% of average. So that's really the biggest change from last year to this year, is the diminished hydro conditions. Overall, the adequacy levels are similar to the summer of 2018, where we had similar hydro conditions. So as a result, adequate imports may be critical in late summer when the impacts of below normal hydro conditions are more pronounced. When we were in 2018, once we got into August, it got pretty mild. We never got to 1 and 2 load conditions in August or September of 2018. So during the period when hydro was more diminished that year, we had some pretty mild weather compared to normal. So there wasn't nothing really materialized that year. This year could be different. We'll just have to wait and see. So adequate imports may be critical late in the summer when the impacts of below normal hydro conditions are more pronounced. In a late summer heat wave, especially if widespread and impacting imports, would be particularly challenging. And finally, adequacy levels are most challenging in the post-solar window, as reductions in the gas fleet have not yet been offset by sufficient storage to offset the loss of capacity available in that window where the solar is no longer available and we are in our peak load conditions for the day. So that ends my presentation. Are there any questions?
So just a reminder, if you have a question, you can raise your hand by pressing #2. And please start by introducing yourself. So Lauren, let me know if anybody enters the queue.
We do not have any questions in queue at this time.
Okay, great, thank you. So next we have Amber Motley. She's going to go over the COVID-19 impacts to ISO loads. ISO load and market. So, Amber, go ahead.
All right, thank you, everybody. Can you hear me all right?
Yes.
All right, perfect. So we have been posting for a few weeks now the impacts of COVID-19 on the California ISO load. The purpose of this analysis is really to dive into the details and look historically at the impact that we've seen on load and prices throughout the different behavioral pattern changes that we've seen going, into stay-at-home orders throughout the state of California, being in stay-at-home orders throughout the state of California, and then now with our next update coming this week, posted publicly, that the release or the start of release of stay-at-home orders on the short-term forecast. It's not a projection of what is to happen similar to what Bob mentioned earlier. We really want to look at this, see what's happening, see how it's evolving, but at this time there's not enough data to project forward the impact that we will see on load long-term with COVID-19 evolving. And we've seen human behavior patterns change. As we go through the presentation, you'll see that in the load shapes as things have moved and evolved throughout the state of California. Next slide. So just a little bit of background. Between March 17th and 19th, we started seeing various California counties go into stay-at-home, work from home if possible. We call this time period the partial stay-at-home period. Beginning on Friday, March 20th, the state of California implemented the executive order for all individuals to stay at home except for essential employees. We started all of our analysis at this point because of the communication being on a Friday prior to the weekend. When we go through the analysis, week one is always going to be considered a Monday through a Sunday, so it will be March 23rd through that Sunday, and you'll see that in the previous slide. Next slide. In summary, weekday average load reductions, megawatt hours, we've seen 4.5% following the first full week of stay-at-home order. This analysis goes through May 10th at this time, and then up to 7.4% reductions during the peak hours, especially the morning peak hour, and you'll see that in the summary slide later in the presentation. We also have added an hourly average load reduction. We've seen the hourly average load reductions range from 2.6% to 12% when looking at March and April, with the highest percent reductions observed during the hours of hour ending 7 through hour ending 18. And then looking at the weekend, we've seen less of an impact of COVID in the historical sense on the weekends, where we have an average load reduction of 1.3%, and then up to 3.8% reductions during the peak hours, again, as the 3.8% is driven from the morning peak hour. I'll go into details of how we've came up with that number in a couple slides in the forward, but we've run a backcast analysis, and I think it's important to highlight. So we, in our analysis at the ISO, are not comparing 2019 year loads at this time to 2020 year loads, or 2018 to 2020, or a 3-year average of previous historical loads to 2020. What we're doing is we're taking the models that we were running with prior to COVID-19's impact and populating those with weather condition actuals, so the actual temperature of the day, the actual behind the meter production of the day, and rerunning that model, and it puts out what we call the expected load. That expected load is then being compared against the actual that was observed on the system. And that is what we call model error, and that model error is what we're analyzing to get the percent reduction. While the load models that we have are very sophisticated, they cannot anticipate the stay-at-home order to a degree. It's evolving over time. So we continue to fine-tune our models and improve forecast accuracy in the day ahead in the real-time markets as the conditions evolve. And then lastly, energy prices we've seen decline by $9 to $10 in both day-ahead and real-time markets, and we don't have any impact at this time to grid reliability from the stay-at-home order. Next slide. This is really just summarizing the pieces that we've talked about before. So moving to slide 21 and 22. So this talks a little bit more about the backcast model that we're using. We know that the largest error, if you're going to compare to previous years, is the difference in weather. So if you were to compare 527 today to last year's 527, we most likely were not hitting 100-degree temperatures.
during that period of time. So that's why we're leaning on the backcast approach to show what the expected load model would have put out versus what actually occurred on the system, and then taking that model error that you're seeing and associating that with COVID-19, allowing us the ability to isolate the COVID-19 impact. The next few slides are going to go through load shape graphs. So I want to pause here and see if there's any questions specifically on what we've talked about to this point before we go into the graphs.
If you have a question, you can press #2.
And we just got a caller in the queue.
All right, thank you.
Please go ahead.
Hi, this is Marcy Palmstrom with Southern California Edison. You mentioned that you're using a Monday through Sunday weekly look, so you started with the comparison on March 23rd. So for the partial stay-at-home, you started on the 17th, which was a Tuesday. Just curious why you didn't include that Monday, the 16th, as a additional day for that week. If there was any reason to exclude
because
it.
The 17th. Yeah, so the 17th was the first time that we saw the major population area, specifically San Francisco, issue their stay-at-home order. They issued it on the 16th for the 17th.
Okay, thank you.
Any other questions, Lauren?
We do not have any callers in the queue at this time.
All right, go ahead.
All right, perfect. So I'm going to go through a few of the load shape graphs. If you do guys have questions on any specific one, I'm not going to go through every week. They're all available out there for you guys to look at and analyze. First week, so we have the partial stay-at-home order and the pre-stay-at-home order on this graph, so you can kind of see the different evolutions that we were going through, the weeks in the model of the expected load versus the actual load before we got into any partial stay-at-home. And then starting on the 17th, you start seeing the load impacts of the partial show up in the shapes, specifically morning, evening peak when you get farther in the graph on March 17th through the 18th. And then if we skip to slide 25, this is a period of time we were well into the stay-at-home orders throughout the state of California, not really in a transitional phase anymore. You can see on this graph the impact of the expected and the actual loads throughout time. You also see that on the weekends, you have some impact and reduction of load during the morning in specific, as well as the belly of the duck dipping out a little bit more. But when you get to peaks on the weekends, those are not as impacted as what we see throughout the week. This was a pattern that was consistent throughout the stay-at-home period. And then let's skip to, I believe it is slide 29.
Oh, 29, Amber, is that what you said?
Yeah. Oh, sorry. I went way too fast. 27.
Okay. This might be a slight delay. There you go.
Yeah, perfect. So this week I wanted to point out, so this was the first time that we saw exceptionally above normal temperatures throughout the system, May 4th through May 10th. During this period of time, we were running temperatures of 7 to almost 20 degrees above normal, very similar to what we're going through now. You do see during those days of, May 4th and into the weekend that there are impacts to the load in the morning, but the evening peak loads during heat have had minimal to no load reduction during these events. Again, we're looking at this in a historical light, so not predicting what is going to happen in the future, but I think it's important to note that the reaction changed when air conditioning loads were activated during the first heat up event. We are seeing, and as we're going through it right now, we are seeing similar impacts right now when we're running 20 degrees above normal, that the evening peaks are very minimally to not impacted at all with COVID-19 orders. We are more in a opening up phase as well right now, so that's something that's moving and evolving throughout. But we also continue to see the most significant reductions to the load during the morning hours, and when I say morning, it's really that morning peak, so hour ending 7, through hour ending 10, all the way into the midday hours through noon and the solar hours of the day. Next slide. In summary, just looking at March 20th through May 11th, morning megawatt percent impact of weekdays, we've seen 7.4%. That's the biggest impact. Weekday evening peak, we've seen 5.7% impact. And then when we get to the weekend, we still see the bigger impact of peak during that morning time period of 3.8%, and the evening peak being 1.3% on the weekend. Overall, megawatt hour-wise, looking at all the time periods between March 23rd and May 11th, the weekdays have a megawatt hour impact of 4.5%, and the weekends have an impact of 1.7%. Next slide. Breaking this out, megawatt hours throughout the different weeks, so you can see the trend of each week, partial, and then going through some different weather patterns throughout. Week 6 and 7, the weekdays, 7 specific is where we started seeing the heat period during that time. That bottom line on that graph for weekday is 2.5%. And then overall on the weekend, we did see a little bit more impact on week 6 on the weekend. That was due to the middle of the day. If you look at the graph, it shows that the middle of the day dipped out significantly during those mild temperature conditions where we have the high sun angles on the system. Overall, we've seen a reduction in load. And then next slide. So this is a new graph. We haven't put this one out in our typical presentation posting. It will be out in the next one with May graph included in it, but wanted to look at the hourly percent difference in the expected load to the actuals over time to see where in the hours the biggest impact is happening. We see that the biggest hour impact from March and May is really hour ending 7 through hour ending 17, 18 time period. What you will see when the next public presentation posts either later today or tomorrow is that May has a different shape, had more heat days in May, and that the biggest impact when May is really hour ending 7 through hour ending 12 or 13. That's where the biggest percent difference is in expected load due to COVID-19. Next slide. And going just a little bit into price impacts overall. Summary is really we've seen $9 to $10 of impact in prices. Prices do have effects of the differences in weather. There's not a backcast run on these prices. So wanted to plot them over time starting March 7th before the stay-at-home orders or COVID impacts were there all the way through May 6th. And then on the next slide, we're looking at the differences of the week throughout time, knowing that there are some impacts of other things within price, load, temperature, transmission outages, generation outages, et cetera. But those are also there for you to be able to view. Next slide. And the 15-minute energy prices have reduced about an average of $10 in the period of the shelter-in-place provision. Next slide. And that is all I have.
Okay, are there any questions for Amber? Again, you can press #2 to raise your hand.
At this time, I don't see any callers in queue.
Okay. Well, there'll be another opportunity at the end. So So next, this is our final topic. We have Ryan Segazio, who's Vice President, Chief Financial Officer, and Treasurer at the ISO, and he's going to cover the GMC rate and EIM administrative fee adjustments. So, Ryan, go ahead.
Thank you, Christina, and good afternoon, everyone. A couple of weeks ago, we issued a market notice to have a rate adjustment, in this case, a rate increase across some of our major charge codes. They go into effect June 1. Typically, a rate adjustment is not a newsworthy event. We do them from time to time to adjust for volume differences. But I think in light of the uniqueness of what's causing this rate adjustment, we thought it'd be helpful to have a little discussion. I've got just a few slides here to kind of walk through it, and then I can open it up to questions. Just to take a step back, when we develop the revenue requirement every year, toward the latter half of the year, take it to the board for approval, we then kind of allocate that to the three main GMC charge codes based on the formulas in the tariff. We estimate the volumes that are going to go through those charge codes for the following year, and then that obviously allows us to set the rates. The tariff describes tolerance levels on how those the volumes, if they start to fall outside those tolerance levels, tariff requires us to adjust the rates up or down depending upon how far they're out of these levels. So I'll talk a little bit more about that on another slide, but that's what's happened now. Obviously, what Amber just described, the COVID-19 pandemic has caused some changes in the volumes that have gone through the GMC codes. We had actually seen lighter volumes in January and February to start the year, even before this, but not enough to cause a rate adjustment. But then obviously with the stay-at-home now affecting some of March, all of April, and now into May, it's caused our annual forecast to now project that we're going to be 3% short of the overall budget, which is outside of the tariff tolerance levels. This slide here just shows you the adjustments in the GMC market services category. It's a ½ cent increase to just under 10.5 cents per megawatt hour. In system operations, it's a 1.5 cent increase to just over 29 cents. And then that also impacts EIM rates. So EIM rates are derived from these two GMC rates. They pay a percentage of that. So anytime there's an adjustment in those rates, it affects EIM rates. In this case, EIM volumes are also down. We were under collecting in terms of EIM projections as well. The combined effect to EIM is about a penny per megawatt hour. You can see that over here to the right. One of the charges is going up about 0.4 of a cent, and the other one just under 0.6 of a cent. So that's the actual rates and what's happened. Next slide, please. So in the tariff, this is all part of Appendix F, Schedule 1, Part B. We monitor this on a monthly basis, the actual volumes going through the GMC codes. If our forecast, differs by the greater of 2% or $1 million, and in this case, the 2% really applies because these are the big charge codes in terms of system operations and market services. If the annual forecast, if we're going to exceed the revenue or be short of the revenue by more than 2%, tariff requires us to make an adjustment. We apply this to each of the service categories independently. That's the three main GMC charge codes. So in this event, the CRR charge code is not being impacted. The volumes are coming in as expected in CRR, so there's no adjustment to the CRR category. But in this case, the other two are outside of the tolerance levels. One other point is that even though we monitor this on a monthly basis, tariff restricts us from doing this any rate adjustment more than once per calendar quarter, and that's to create some uniformity and not have volatility, too much volatility in the rates. Next slide, please. So even though we adjust these rates fairly infrequently, it's not uncommon. I mean, we do have volume variances throughout the years. Typically, it's more weather related. It's not a stay-at-home, shelter-at-home order, but it's the other thing I want to point out here, these rate adjustments only happen for volume forecast variances. So the tariff describes that if the volumes are, again, outside the tolerance levels, we can adjust rates. We cannot do that for expense variances. So if we were running over budget during the year, we cannot do a rate adjustment for an over-budget performance or an under-budget performance. Those variances are handled at the end of the year during the operating reserve cost adjustment that affects the next year's revenue requirement. The reason we have this tool in the tariff, there's really two main reasons. One, we need to ensure we can collect the budgeted revenue. So this is important for the rating agencies and for our bondholders, that we have the ability to collect, the revenue, which is, again, the ISO's cost. It's the recoupment of the cost. And this removes the financial risk of any, weather or other types of impacts to volumes that we can't forecast when we set the volume forecast at the end of the previous year. Second, this really lessens the impact of larger adjustments on future revenue requirements. The ability to have this tool and adjust during the year, allows us to make a correction and not have a larger impact next year. I think in the market notice, the forecast was showing that we were going to be about $6 million under collected under the existing rates. If we did not have this ability now, and let's just say that even got worse, we could have ended the year potentially $10 million under collected. Now we have the reserves, the operating reserve that would allow for the cash flow component to work out. But that $10 million would then have to be collected in the future revenue requirement, which is a bigger hit to the market. So this allows a smoothing out of some of the volume variances during the year. So that's all I have for a prepared presentation, but happy to answer any questions.
Okay, again, just a reminder, you can raise your hand by pressing #2.
All right, and so far I'm not seeing any questions in the queue. We can give it a few more moments.
Sure, let's do that.
All right, we have had a caller enter the queue. Please go ahead.
Okay.
Hi, this is Tariff calling from SEN. And actually, this question is for Amber from the previous presentation. Assuming you've opened up the general questions on all the presentations.
Yeah, no problem. Go ahead.
The question is on the price analysis due to COVID-19. So the $9 per megawatt hour, so what methodology did you use for that? Are you just comparing the last week compared to the first week, or are you using a similar backcast methodology as you did for load?
So the price components are not using a backcast methodology. They're just comparing previous weeks of, before the stay-at-home orders and shelter-in-place went into effect.
Great, thank you.
Have we had anybody else enter the queue?
At this time, we do not have any other callers in the queue.
Okay. So just a quick reminder to everybody that the ISO is launching a new stakeholder commenting tool. And so we did host a meeting on May 8th where we demonstrated the tool. We did record that meeting, so if you didn't have an opportunity to participate, you can go out to that miscellaneous stakeholder meetings webpage and you'll find the video link there. That's also where you'll find the presentation for today's meeting. Some of the benefits of this new tool is it gives stakeholders the ability to view all comments with a single click. Before, you had to open individual documents, or the way it is now, I should say. So this will give you the ability to view those comments in a single click. You can view them by either organization or by question. And you can also download, it'll be a template, like a form, and you'll be able to download that form. So if you want to type in your comments in that form and then upload them, or not upload them, excuse me, and then paste them into the tool, you'll have the ability to do that. Prior to being able to submit comments, you will need to be, there's a very quick registration process. So you just need to register your name, but once you're in the system, that information stays there. So are there any questions about the new commenting tool? Again, you can press #2 to raise your hand.
This is Joanne Serena. So just a quick additional comment on that. The launch date has not been determined yet, but we will let participants and customers know of our launch date through a market notice. We'll also be conducting some training right at the time of launch. So just stay tuned for some announcements to come out with that information.
Thank you, Joanne. So, Lauren, do we have anybody in the queue?
We do not have any callers in the queue.
Okay. Well, we greatly appreciate all of you participating today. I did provide a resources slide that links to the summer assessment as well as the GMC rates. So those two documents are available there. The presentation, again, is out on the miscellaneous stakeholder meetings page. We'll probably receive the recording for this meeting. I would expect it to be posted by early next week since we're already in the middle of this week. So again, thank you. Enjoy the rest of your afternoon, and thank you to our presenters.
That concludes our conference. Thank you for using Event Services. You may now disconnect.